Assalamu alaikum. Welcome to the second lecture of DSP. In this lecture, we are going to discuss the definition of signal and systems and some important operations which we perform on signals and some other stuff. First of all, the definition of signal. Signal is a description of one parameter which varies with the other parameter. In this, one parameter is independent variable and the other parameter is dependent variable. For example, voltages and brightness. Voltages changes over time. The time here is independent variable. Brightness, in brightness which varies with respect to the distance. In this, distance is the independent. System processes the signal to create the other signals. Any process that produces the output signal in response of an input signal is called a system. For example, if we give the input to a circuit or a system or an algorithm and it gives us the desired output, then we will call that algorithm or that circuit as system. There are two types of systems, analog systems and digital system. Analog system works on continuous signal and digital systems works on discrete signals. Now let's see some examples of the systems. Here we have an averaging system with an equation y of n is equal to 1 over 5 and the summation of ranges from k to minus 2 to 2 x is into n minus k. Our next topic is operations of signals. Here we have an example of flipped signal. We have x of n given in the first figure and y of n given in the second figure. Now we have the shifting operation. Y of n is equal to x of n plus 4. Through this equation, our graph will move to the left side 4 steps. In the second example, y of n is equal to x of n minus 2. Our graph will move 2 steps to the right side of the axis. In indexing operation, y of n is equal to x of 2n. It will shrink the signal with the factor of 2. By doing this operation, we have information loss. In the next example, we have y of n is equal to x of n over 3. We can expand the signal by doing this operation. Now see an example when we have to perform the multiple operation on a single signal. We have x of n. First we will shift the signal 3 steps. Then we will flip the signal and at the end we will do scaling or indexing. After performing the basic signal operation, we will transmit the signal from the transmitter and it will receive at the receiver end. Now the main issue is at the receiving end is getting the information back from the signal. If we have done scaling of the signal, for example, we have expanded the signal or we have contracted the signal, some of information will be lost in case of contraction. To get this information back, we have some operations which we perform on the received signal. First operation is called zero order hold. In zero order hold, we put the value of the amplitude from the previous sample if the amplitude is 0. It means that if we have no value of the signal at the instant -1, we will use the same value at the previous sample which is 0 at -1. The second method is first order hold. In this method we use the trapezoidal rule and assume the value of the missing sample according to the trapezoidal rule. For example, we take the derivative of the signal and draw an assumption at the missing sample. For example, at -5 there is no signal sample. We take a trapezoidal rule and derivative of the signal at point -4 and -7 and assume the value at -5. The next method is second order hold. In this method we use 3 points and 3 samples. Averaging the 3 samples, we will get the required values, or you can say the assumed value at the missing sample. Now let's talk about some special signals. First of all, we have unit impulse. In unit impulse, we have an impulse at instant 0. The equation is 1 at n is equal to 0, and otherwise it will give us 0 value. Unit step signal. Unit step signal give us one values for all the samples greater than 0 and for 0 value for all the samples less than 0.